In this video, we're going to talk about the intermediate value theorem for integrals. There is an intermediate value theorem for derivatives that you might remember, and this is somewhat similar, but we're going to use it to kind of help us think about some other things here. So first off, I want us to remember a definition that we've seen before, and that's the average value of a function. So the average value of a function, and that again is talking about the average output or y value. So this is sort of taking a look at all of the y values you get out of this function on this interval a to b, and on average your y values would be this f sub average, and we get that from doing 1 over b minus a times the integral from a to b times f of x dx. So this leads right into the mean value theorem for integrals, which says that there's some point c in between a and b. So c could be a or b because those are included. So this little kind of e-looking guy, that means that c is an element of that interval, meaning that c is some point in between a and b. And so there's some point, at least one, and there may be two, in between a and b where we can plug that x value into our function and get our actual average value. So this is telling us that there's some point c that's equal to that average value, that average y value. So that average y value is an actual output of this function for some x value, at least one, in that interval. Sort of what that's telling us. And then another way to write that is also then saying that our definite integral is equal to that average value times b minus a. So that one's a little bit funny to look at. So I've got kind of a nice picture that shows what it's talking about here. So in this picture that we have down below, we've got, so I took this from a different book. So this f bar, that is the average value. That bar over the top, that's another way that mathematicians talk about an average. So what we did is found the average value, and it's right here. That's this output right here for this function on this interval that we're looking at. This is our average output, and it's f of c. So there's some point in our interval that's the output's equal to that average value. And then what it's saying is that this integral from a to b, which is our area under our curve, it's equal to the rectangle. So this makes a rectangle. So this is the height of the rectangle, and this b minus a is the width of the rectangle. So what that looks like in that picture here is here, this amount right here that I'm highlighting in green, that is b minus a, and that's like the base of our rectangle, or the width. And then how tall it is f of c. And so that area that we make with that red sort of rectangle there, that's the same as the area under the curve. And if you kind of take a look at this part of our graph right here, I'm highlighting in purple, that's the same amount of area as right here. So we can kind of flip that down, and that does make a rectangle. So it's kind of just an interesting fact about integrals. So how we've kind of done these things so far is that we've found some average values, on an interval -2 to 2. So this is asking us to do let's not be bright red here, the average value is going to be the integral from -2 to 2 of this absolute value function dx. Oops, and I left out a part, didn't I, for average value? We need to have the 1 over b minus a. That's b, there's a. So this is equal to 1/4 times our definite integral that we've got right here. So I drew a picture of this one. We will very, very shortly talk about how to find these integrals without using area, but we can use the area for right now. And we've got basically 3 areas that we need to take a look at here. We've got 2 triangles, and we've got 1 big rectangle. So our first triangle here it is got a base of 2 and a height of 2. Our second rectangle or triangle here, excuse me, I keep calling those triangles, and it's got the same base and height. And then our last one here, sorry for getting some background kitchen noise from my house there, its width is 4 and its height is 1. So we get 1/4, and then 2 plus 2 plus 4, so we get 1/4 times 8, so which is 2. So that's our average value. So I'm going to take off this area stuff we were doing here. So that's telling us that on average, in between our interval here, so from -2 to 2, our average output value is 2. And there's 2 places where that output value occurs. And also in terms, so we could, I'll do the other thing here in a second. Got a little ahead of myself. So find the value C such that our input, when we plug it in, we get that average value. So we know what the average value is, 2. We know what our function is. It's the absolute value of x plus 1. And sometimes what we do, instead of putting an x in there, we'll put a c in there to say we've taken that number c, plugged it into our function. And so if we solve this, we get 1 is equal to the absolute value of c. So that tells us that c is going to be +1 or -1, which is exactly what we could see from our picture. There are 2 places where we get that actual output. But also in that sort of picture, where it's saying that the area under our curve, the area from -2 to 2 of our function here is equal to that f of c times b minus a. So in this case here, our f of c is 2 and f of b minus a is equal to 8, which was our area under our curve. And we can kind of see it also from our picture here. If we take that height being 2 and b minus a is our length, here this area